Hello everyone, welcome to the channel Learn Math with Shobita. Today I am discussing some properties of open and closed sets in real number system. Okay, the question is an open set in R is option A an interval, option B finite union of open intervals, option C countable union of disjoint open intervals in R, option D intersection of open intervals. So what do you mean by an open set in R? A set is said to be a subset of a real number system is said to be an open if it contains all its interior points. What do you mean by an interior point? A point belongs to a set is said to be interior point of that set if every neighborhood of that set contains every neighborhood of that point is completely lies in that set. Then we say that the point is an interior point. Okay, so now let us analyze each option. So what do you mean by an open set? An interval means it may be closed interval, open interval or half open intervals. So intervals are three types. So here it is an interval means it may be open interval, may be closed interval or it may be half open closed interval. So closed intervals are not open. Similarly, half open, half closed intervals are also not open. So an interval means it is not an open set. Interval is open if and only if it is an open interval. Okay, so option A is not possible. Next, let us see some properties of open set. Open set properties. The union of an arbitrary collection of open subsets in R is open. Union of an arbitrary collection of open subsets in R is open. So finite union of open intervals is also an open set. Okay, because arbitrary union is open, so it's therefore finite union is also union of open intervals is also an open set. Okay, next, the intersection of any finite collection of open sets in R is open. So for the intersection, for only finite collection of open sets in R is open. So on the section in the option D, they have given intersection of open intervals. So it is not, they have not given whether it is arbitrary intersection or finite intersection. So in the case of open sets, only the intersection of finite collection of open sets is open. So in general, intersection of open intervals is not an open set. Okay. So now let us see one example. Consider Gn open interval 0, 1 plus 1 by n for n belongs to n. Note that Gn is open for each n belongs to n, because for each n belongs to n, each G1, G2, G3 are open intervals. They are 0, 1 plus 1 by 2, 0, 1 plus 1 by 3 and likewise. So each one is open. Now what about its arbitrary intersection? Let us see. The intersection G is equal to intersection from n equal to infinity Gn will be half open closed interval 0, 1, which is not open. So in general, we cannot say intersection of open intervals is not an open set. Thus, intersection of infinitely many open sets in R need not be open. So therefore here option A, an interval, it is not an open. So this is also wrong. Next, intersection of open intervals, this is also not open. Finite union of open intervals is open. Then what about this countable union of disjoint open intervals? Let us see. We have one theorem. A subset of R is open if and only if it is the union of countably many disjoint open intervals in R. This is one of the characterization of open sets. That is, a subset of R is open if and only if it is the union of countably many disjoint open intervals in R. Therefore, by above result, option C, that is countable union of disjoint open intervals is open. Okay. So here options B and option C, they are correct. Countable union of disjoint open intervals is also open. Finite union of open intervals is also open. So answer for the above questions I have given. Now let us discuss some additional informations. So already I have told that arbitrary intersection may or may not give open sets. For example, consider another example. Let us equal to intersection, arbitrary intersection of the open interval minus 1 by n, comma 1 by n. Each open interval minus 1 by n, comma 1 by n is an open set. But their intersection is open interval minus 1 comma 1 intersection open interval minus half comma half intersection and so on will be singleton set 0, which is not an open set. Thus here it is an example where intersection of an infinite collection of open sets is not an open set. Now consider another example. Let us equal to intersection of n equal to 1 to infinity open interval minus n by n plus 1 comma n by n plus 1. So this will be minus 1 by 2. If you put n equal to 1, you will get minus 1 by 2 comma 1 by 2. Intersection minus 2 by 3 comma 2 by 3 intersection and so on, which is equal to open interval. This intersection is all equal to minus half comma open interval minus half comma half, which is an open set. Thus, here it is an example where intersection of an infinite collection of open sets is open. So, arbitrary intersection, it may give open set or may not. Okay, these are two examples. Now, similarly, we say what about closed sets? Closed set properties. The intersection of any family of closed sets is closed. Okay. In the case of open set, intersection of a finite collection of open set is open, but in the case of closed set, intersection of any family of closed sets is closed. Also, the union of any finite family of closed sets is closed, but in the case of open set, arbitrary union of open sets, arbitrary collection of open subsets is open, but in the case of closed set, union of finite collection of closed set is closed. So consider let Fn is the closed interval 1 by n comma 1 for n belongs to n. Here each Fn is closed, but the arbitrary union is half open closed interval 0 comma 1, which is not closed. Thus the union of infinitely many closed sets in R need not be closed. Another characterization of closed sets, let F subset of R, then the following assertions are equivalent. F is closed subset of R. If Xn is any convergent subsequence of elements in F, then limit of X belongs to F. Okay, limit of the sequence belongs to the closed interval, closed subset. Another theorem, a subset of R is closed if and only if it contains all its limit points. Okay, closed sets cannot be expressed as the intersection of a countable collection of closed intervals in R. This is, we have told in the case of open sets, a subset of R is open if and only if it is the union of countably many disjoint open intervals. So similarly, in the case of closed sets, we cannot express closed sets as the intersection of countable collection of closed sets, closed intervals in R. Okay. When we check whether a given set is closed or not, a set is closed if and only if its complement is open. Okay, this is another point. So remember, the union of an arbitrary family of closed sets may or may not be a closed set. For example, let An is equal to the closed interval minus n by n plus 1, comma n by n plus 1. Then the arbitrary union will be open interval minus 1, comma 1, which is not closed. Okay, this is an open. Here each one is closed, but their arbitrary union is open. Here each An is a closed interval, but their union is the open interval minus 1, comma 1, which is not closed. Let an is equal to closed interval minus 1 by n comma 1 by n. Here the union will be closed interval minus 1 comma 1. Here each an is closed and their union is a closed set. Another example, an is equal to closed interval 1 by n comma 2. Here the union of an will be half open closed interval 0 comma 2, which is not a closed set. Let an is equal to the closed interval n by n plus 1 comma n plus 1 by n plus 2, and the arbitrary union will be half open closed interval half comma 1, which is not a closed set. Thank you friends. Please share and subscribe the channel.